Hi guys, welcome to the Code4 Academy. We are going to discuss about how to write a clean code as a software engineer, right? So we will discuss on that. Let's get into the session, guys. Thank you. Hi guys, welcome to the Code4 Academy. We are going to discuss how we can write a clean code as a software engineer. How to write a clean code in a project, right? When you are defining the variables, right? Variables are method names. Variables, it has to be a meaningful name. You don't need to comment that. Like we have to, we will not write define the variable like one letters or two letters. It has to be write a meaningful variable names, right? That has to be defined. And method naming convention, when you are writing the method name, it has to be clean and very meaningful method name, right? It has to start with the small case letters and then it has to be proper naming convention. And the method length has to be it has to be less than 30 lines, as per my experience I'm telling. So when you are doing more than 100 lines or 200 lines of method, then we have to break up into multiple smaller methods like private methods. Some of the method may be reused by other people, right, or other use cases. So we can break up into multiple methods so that it will be more cleaner and neat, right, when you are seeing your method, right? So method name, we will not write more than 30 lines. If you are going more than 30, then we have to be break up into multiple private smaller methods. Sometimes we need to reuse methods in other projects or other, sorry, in the same projects by other use cases, other people, right? So in that case, we can define move to the method to the utility classes so that we can reuse by other use cases or other component can reuse that, right? And understanding the use cases, we need to understand the properly our use cases. If sometime if you have questions, or we can discuss our testing team has the high visibility of use cases, all the use cases you can discuss with them, and you can test all our use cases, right? And then when you are writing the code, we have to always use the enhanced codes, right? If a Java, let's say Java 17 version you are using, but we will not write a code in Java 7 version, so that is not acceptable, right? So we have to always consider the efficient code. We can search in Google how to write this logic, and you can get the enhanced version logic, right? So some of the instead of using for loop has to be enhanced for loop. Sometimes for loop iterating the list, we can use lambda expression, right, in the enhanced Java versions. So like that you can, in any language, Node.js or Java, you have to always write enhanced versions, and we have to be efficient code we have to write, right? Efficient code means we have to use the enhanced features. Instead of using the basic things, we have to use enhanced or advanced feature we have to use in our code, right? And then configuration. When you are writing the code, the configuration value, we have to move to the some configuration properties, right? Property files. Instead of hard coding inside the Java class or any framework like Node.js or any language, we have to write the configuration property has to be decoupled. It has to be cleaner way. It has to go to the configuration properties. So, and then when you are writing the code, we have to follow the proper patterns. Patterns means we have to write a proper value object or business object. When you are persisting to the entity object, it has to be proper named, and we have to use proper getters, proper fields we have to use, and we have to write in the correct exact layer, like manager layer. If there is any business logic, that has to go to manager layer. If there is any service level logic, if there is any service layer like service related logic, that has to go to service layer. If there is any database logic, then it has to go to database layer. Layer means it is a DAO class, database DAO class, or a service class or component, manager component. Like that, we have any project that has to, we have to follow the pattern like properly. We should not, we will not keep the entire logic in REST component. Let's say Java Spring Boot, a REST controller are there, right? We cannot keep all the entire logic into the one component like REST component. It has to be thin layer. We have to move the business logic to the business layer, and database logic has to go to database layer, right? Like that we have to write. And once we have completed, then we have to get it done the proper code review. So we have to assign the code review and then get it code reviewed. So, and we have to incorporate that, right? And data, we have to testing that. When we are testing that in changes, you have to take the data from our higher environment like Q environment or any of the environment. You have to
export and import into a local environment, right? So the data, so that you will not face any kind of data quality issues while testing, right? So you will in your local, right? So you have to get the proper data. Sometimes you can write the JUnit test cases. If you have bandwidth, you can write the JUnit test cases, you can test our changes, right? Use cases, and you can test that. But some of the things you can ignore that, some cases, because it will take more time testing, writing test cases, JUnit test cases. We can sometimes, some cases we can avoid that, right? And then the next thing is, you are going to write is service integration. When you are writing the service, let's say you are going to call some external service like get customer data, get order data, which is coming from different system, different external system. So when you are writing that, we are going to write a new or existing, means you need to understand that how the service are written. Based on that, you can go for the changes. You are going to write a new service component you are going to build. For that, then you have to understand the payload structure, request and response payload structure, and what are the header parameters we need to make a service call, and you have to understand and adding the parameters, and then you have to test it before going to the implementation phase. You have to test the error cases, and you have to test the positive scenarios and negative scenarios, and then you have to go to the implementation level. So when you are writing implementation, timeout is nothing but how long the service has to wait, the client has to wait. Let's say client is calling the service, but service is not responding. So we should not keep, we should not keep calling that, right? It will create some memory issue, and it will go to the servers down, or some memory issues will happen. So what we can do is, we need to check the pattern certain time, like few seconds or 10 seconds or 50 seconds. It has to wait until the service is ready. And if something 50 seconds is not ready, or 1 minute is the service is not ready, then you have to time out, you have to exit the request, right? So that's the reason we are going to use, like in Spring Boot we are using circuit breaker, which is a fallback, which is fault tolerance and handling the error cases, right? So that's the reason we are using circuit breaker kind of design patterns we are using, right? And then fallback is something, your current logic, something is going wrong, then what we can do is, we can execute the fallback mechanism. Let's say you are right, you are calling the actual service, but service is not giving the expected result or error. Then we can execute the fallback. Instead of calling the service, we can retry from the database. That, based on the use cases, we can decide. And error handling, you have to handle the proper error handling. When you are calling the service may give the proper error code based on the use cases, or based on the scenario. It will give different error code, and we have to map the proper error message with the error code, and we have to display the proper error message to the client. So client side, we have to map the proper error code with the proper error message. That's very important when you are writing the services, or when you are changing the services, when you are writing the new services, right? And then retry logic, sometimes we have to retry that. So when you are calling the service may cause some issues, and we have to going for retry. We are keep it in the queue, and queue will retry the service, right? So that kind of retry logic, whenever we record, we need to implement that. And then this, what we have done so far is synchronous API call. If you go for asynchronous call, it's nothing but a messaging framework, right? A messaging framework like Kafka or RabbitMQ, right? When you are writing the placing that, when you are calling that, most of some use cases is like fire and forgot means your request is sending, but response is not expected. So this kind of use cases will come in the analytical data. You are keep on sending, including to duplicate data, you will not, no matter. But when you are going some critical use cases like banking scenario and all, when you are fire, it has to give the expected response, it has to be acknowledged properly. Then only the request flow is success, and it will go to the next line or next level, right? So that has to be very important when writing the messaging framework, right? When you are implementing the messaging framework. And performance impact, we need to check the properly high throughput we need to test, and whether how the response is coming. We can go to the monitoring tool, and we can check that how the APIs are responding, what is the latency impact or latency time, and we can check that is it really reduce the latency, or any latency impacts are happening, right? And another thing is cache implementation. When you are implementing the cache, that will come from the architect or lead will tell you whether this scenario we need to go for cache. Let's say we are repeated logics, we are fetching from the database or we are fetching from the service, right? Repeated logic, repeated data for certain users or certain customers, where repeated data we are getting. So instead of multiple times you are calling database service, we can keep it in the data in the cache, and then from the cache we can retrieve the data from the cache, and then so that it will reduce the latency, it will improve the performance. And we need to check that actually really it is happening or not. We have to go and check the performance, load testing we have to done, and we have to check that what is the performance impact, and we have to see the monitoring tool, what is the latency. So we have to check that, so that then only we can say our cache implementation is success, right? And we have to keep the limited amount of data in the cache, because sometimes it may cause memory issues or memory kind of leaks may happen. So that's based on the use cases, you can take care of that, right? And then cache invalidation is another case, a very important case, because when you are calling this cache, sometimes backend side the data get changed or database data is get changed, but still you are fetching the old data from the cache invalidation, from the cache. That is not acceptable, right? So you need to always sync the cache with the backend system or database system or service. You have to sync that. So how often the data is going to be invalidated, so that you need to know that, and based on that you need to invalidate the cache, whether one every day or every hours, or so you need to check that. Based on that you need to invalidate the cache. And last thing is dependencies. How we can implement the dependency. So when we are implementing the dependency, so dependency it will we may check the version. Let's say Spring Boot, we have to check the Maven dependency, we have to check the version, and we have to always keep the latest version when we are integrating the dependency, because without dependency we cannot integrate something which is related to that, right? Dependency, right? We need a jar, so that jar has to be version mapping has to be proper, and we need to done the vulnerability scanning has to be gone through. There should not be any vulnerability issues, right? When you are integrating the jars, right? We should not we cannot copy directly the jars and put it in the code base. We have to always definition mapping has to be there, and the jar has to be hosted in the external system. It should not we should not keep it inside the code base. We have to always keep it in the external system, and we have to referring that, right? So only mapping has to be there in the code. We will not keep the jar inside the code base. That is a best practice which we need to follow that, right? So these are the things we need to follow when writing the code base, right? Thank you for watching and listening. We are looking forward to join our Cloud4 Academy.